This recording is to help you with lesson 4.08, which is your applications and models. So we're going to start out by solving a right triangle with the pictures drawn here. What I'm going to do is I'm going to change these so they're decimals instead of minutes. So 12 degrees in 15 minutes, that's 12 plus 15 over 60. 15 over 60 as a decimal is 0.25. So I'm going to use 12.25 in my calculator from here on out. What you need to make sure right now is that you are in degree mode in your calculator. If you are not in degree mode, you will not get the correct answers here. Okay, I know that angle A is 12.25, angle C is 90. I can easily find angle B by subtracting those from 180, and I'll get 77.75 degrees because I know that there are 180 degrees in a triangle. And the side lengths have a little bit more work to them. I know that C is 430.5. So what I'm going to do then to find angle A is I'm going to use sine, because I know that this is 12.25. So sine of 12.25 equals A over 430.5. To solve for A, I multiply by 430.5 on both sides and type this into my calculator to get approximately 91.34. And then the same process can be used to find side B. You can either use cosine from angle A, or you can switch it up and you can do sine from angle B. But let's stick with angle A since that's what we're dealing with here. Adjacent over hypotenuse is cosine. So cosine of 12.25 equals B over 430.5. Multiply both sides by 430.5 to get approximately 420.7. The next one is a little bit trickier. You have to find the altitude. Remember, the altitude is the height of your triangle. It forms a 90-degree angle with the base. We know that theta is 52 and our base is 4. So drawing in that altitude down here, I get this picture right here. To find the height, we would use opposite over adjacent. So which trig function is opposite over adjacent? That's tangent. So tangent of theta is h over 1/2 the base. We want to solve for h, so we want to find that altitude. So we have to multiply both sides by 1/2 b. So h equals 1/2 b times tangent theta, and let's plug in the values that we know. We know that b is 4 and theta is 52 degrees. So typing this into my calculator, I get approximately 2.56 inches for the altitude or the height of that triangle. All right, the next one seems complicated, but it's not too bad. We need to find the height of the flagpole if we're given all that information there. And the height of the flagpole is really this distance right here. So the first thing we want to find is the distance from the ground to the top of the flagpole. So from here all the way to the top. And that's using the 39 degrees 45 minutes. Well, 39 degrees 45 minutes is 39.75 as a decimal. Now I'm trying to find the height, so that's opposite, and I know adjacent. Opposite over adjacent is your tangent function. So tangent of your 39.75 equals your height divided by 100. To solve for h, you multiply both sides by 100. So 100 tangent of 39.75 degrees is approximately 83.169 feet. So that's the height from the ground all the way to the top of the flagpole. Now let's do just the height from the ground to the top of the building, which I'll highlight in blue. So we want to find that part. So we're going to do tangent of 28, because that's the smaller triangle, equals h over 100. Multiply both sides by 100. And I get approximately 53.17. So what we can do to find the height of the flagpole is just use subtraction. Let's do the height from the ground to the top, which is at 83, minus the height from the ground to the building, which is 53. So 83 minus 53 is approximately 30 feet. We're going to work on finding the angle of depression first. Note here that your angle of depression and theta actually make up a right angle. Right? So we're actually going to work on finding theta first in our picture. And we are given opposite and the hypotenuse of that triangle. So opposite and hypotenuse is the sine function. So sine of theta is opposite is 4,000, hypotenuse is 4,150. To get theta, we want to move sine to the other side. The only way to move sine to the other side is using the inverse. So we would have sine inverse of 4,000 divided by 4,150. That gives you approximately 74.5 degrees for theta. Right? We don't want theta as our answer. We want that angle of depression. So we're going to subtract theta from 90. So 90 minus 74.5 is 15.5 degrees for your angle of depression. The last one is kind of the same idea and concept with that angle of depression. We want to find the distance between the two ships. So we're going to find the distance from the ship to the lighthouse in each case. And then we'll subtract those distances. All right, so we're looking at this triangle first. That's the closer one towards the lighthouse, so that angle right in here is 6.5. We have opposite over adjacent, so that is tangent. So tangent is 6.5, the opposite is 350, adjacent is D. Remember, to solve for D, you really want 350 divided by tangent of 6.5 degrees. Right, that'll give you the distance of approximately 3,071.9 feet. Same idea from the further away boat. I'll do this one in pink. This time we have that angle of depression or elevation, depending on how you look at it, as 4 degrees. So we have tangent of 4 equals 350 over D. And to find the distance this time, it is 350 divided by tangent 4 to get approximately 5,005. Okay. Now to find the distance between the ships, you just subtract them. So 5,005.23 minus 3,071.91 gives you approximately 1933.3 feet.